Hey guys, welcome back to another tutorial, and in today's video we're going to be talking about addressing modes. Addressing modes are ways of accessing data from memory and storing them into our registers. Now to begin, in the previous video we wrote this simple instruction LDAA, and then we followed it by the pound sign, and then we wrote our number here, whatever that number was, 4, 3, 5, that number doesn't matter. So because we have that pound sign in front of the number, we can identify that this is an immediate addressing mode. It is called an immediate addressing mode, and what is happening is A is being equal to that number that we just wrote. And so the number that is right after the pound sign, that number is being transferred or stored into accumulator A. Now I programmed this program a while ago, and it'll help us understand and see more easily what is going on every time we use immediate addressing mode. And so let's write, for example, LDAB, and then immediate addressing mode starts with the pound sign, and then 2. Now we can see that in register B, or in accumulator B, the value 2 that we wrote is immediately being transferred into the accumulator. What if we do LDAB and then let's just store it back to 0, and then we do the pound sign and then the dollar sign of 20. So why is 20 not being immediately transferred into B? Well, that's actually not true. It is happening. The dollar sign means that the number that we're writing right now is going to be in hex, and then 20 or 20 in hex is 32 in decimal. The next addressing mode is called direct addressing mode. Now, if you understand direct addressing mode, it'll be very easy to then pick up the remaining addressing modes. So far, every time we wanted to access data or store data in accumulators, we would use the pound sign to grab the number after it and store that into the accumulator, and we said that that is called immediate addressing mode. But most of the time, and often, you would need to actually address or access memory and grab the content in memory and store that into the accumulator. So let me tell you what I'm talking about. Let's say we are going to move the number 5, and because I wanted the number 5, I used the pound sign, into memory location, let's say 20 in hex. So now what this instruction does is it takes number 5 and put it into memory location 20 in hex. Now, instead of writing LDAA and then pound sign 5, what this will do is grab the number 5 and putting it into accumulator A. Instead of doing that, let's do the direct addressing mode way, where I'm going to just write the memory location number. What is the memory location number in this case? It is 20 in hex. So now what this will do is it will go to memory location 20 and grab the content there, which we said is 5, and storing that into accumulator A. So let's run the program and see if it does what I said it's going to do. So let me go to memory location 20. It's actually right there. Here we go. You can see memory location 20 is highlighted in blue. And right now it says 0, so there is nothing in it. So let me step through this one time, and you can see now that it has 0.5. So we moved 5 into memory location 20. Now when I do LDAA 20, it's going to, in hex, it's going to go here and grab this 5 and storing it in A. Right now A has CB, which is the default value. And when I do this, now it's 5. So this is called direct addressing mode, where you access memory to copy the data and storing it into the accumulator or the register. The next addressing mode is called extended addressing mode, and it's the same exact thing as direct addressing mode, except that when you're trying to access a memory location bigger than FF in hex, that is called extended. So right now because this is 20 is less than FF in hex, so this is called direct. If you have FF, let's say the memory location is that you're trying to access is FF, this is still called direct. The second you do 1FF or 100, this is now called extended addressing mode. 100. This is now called extended addressing mode. The next addressing mode that we're going to learn is called indexed addressing mode. And for this one, we have to learn how to identify a constant in a different way. So far we learned how to identify a constant using the dc.p method or keyword. So this will identify the constant named con with the value 1. Actually, now with the value 1. But we are going to now learn something called the EQU keyword. And for this one, what is happening here is con1, we don't have to write the pound sign here. Con now is being equal to exactly 1. So every time you write con in your program, it's basically the program will replace that with the number 1. So for demonstrating addressing modes, we're going to let con equal the memory location 20. Now we're going to move a number to that memory location. So we're going to move number 6 into con. So you can either say 20 or you can just say con, and the program will replace con with 20. So why would we need names for memory locations if we can just use the number? Well, because sometimes you want to make sense of memory locations. For example, if you have an output port that is LED or a switch, and every time you're accessing it, you write FF3 or something, you want to, instead of saying FF3, you want to say LED, and so the program now will make more sense. Same thing as with variables. After that, we're going to load x with 20. So we can either do 20 like this, or we can do the pound sign and then con. So now x will be exactly the hex value 20. Now comes the actual addressing mode, which is called indexed. So when we do LDAA, we're going to write a number and then comma and then the indexed register. So 0, x. What this is doing is it's replacing x with its value, which is going to be 20, then adding 0 to it. 0 plus 20 in hex is just 20 in hex, then going to that memory location and grabbing the value there and storing it in A. So let's see that happening here. I'm going to go to memory, location 20. Now it's highlighted in blue, and you can see that the value in there is 0. After I run this instruction, now number 6 is written to it. Pay attention to x. X is CB, CB. A is CB. These are just the default values, so nothing in them right now. Now when I run this instruction, x will be 20, as we said, which is the value of con, the constant. Now when we do LDAA, we're expecting x now to be the value that it is, 20. The program will go to memory location 20, grab the content there, which is 0, 6, and storing it into A. And A is now 6. The next 4 addressing modes are very much related to each other and are very close to the indexed addressing mode. That's why we started with it. So they're called pre-auto increment, pre-auto decrement, as well as post-auto increment and post-auto decrement. And we're going to be talking about what that means. So let's give an example here of loading B with 1 comma plus x. You can see here that it's very similar to the addressing mode, except that we have this plus sign before. So let's also write the example for the pre-auto decrement mode, which is going to be LDAB 1 comma minus x. So we have the plus x and then we have the minus x. And for demonstrating purposes, let's define some variables or some numbers into memory. So let's move the number 4 into memory location 20. And let's move the number 5 into memory location 22. So now 4 in memory location 20 and 5 in memory location 22. And we're going to make x to be 20. So now x is 20, and for the first one here, for when we're trying to load b with 1 comma plus x, what is going to happen is the program is going to make x to be equal to 20 and hex, add 1 to it, so that's 21, and then access that value. And so we're actually going to make x here equals to 21. That'll make more sense. After that, for the LDAB 1 comma minus x, the program will take x, which is 21, subtract 1, which is 20, and then store that information into b. So we should have first b to be 5, then b to be 4. Let's see if that's true. And we can go to memory address 20 here. So now 20 is 0, 21 is 0, 22 has 0e, but that should be overwritten. You can see here now that 20 is 4, and 22 is 5. And x now here, after I run this instruction, should be 21, and that is true. Then we're going to load b with 1 plus x. Now b is basically, the program is adding 1 to 21, so it's coming here to 0, 5, and it's grabbing this information and storing it in b. Now you can see here that x is 22. So when we do this one, we're doing 1 comma minus x. So x minus 1, 22 minus 1, and then it's going to grab that information. But we actually wanted to have the 20, not 21. And so in order to access memory location 20, we need to actually do 2 minus x. Now let's go back to memory. Location 20, 4 and 5 and 20 and 22 respectively. X is 21. Add 1 to x, so that's 22, and then access that memory location, so that's why b is 5. And then subtract 2 from x, 22 is going to become 20. Access that memory location and add that and store that value in accumulator b, so now b is equal to 4. Now the last two are called postauto increment and postauto decrement. So what is going to happen here, instead of writing the plus and the minus before the x, we're going to write them after the x. And that will change the information that are going to be stored. So for this example, I added this line of code, so we're moving 3 into memory location 21. We're actually going to access the information in x first and then subtract 1. So let's go to memory location 20 again. Right now it has 0, 0, 0, 0, 0, e in 20, 21, and 22. So let's write these values. Now you can see 4 is in 20, 3 is in 21, and 5 is in 22. Okay? X is now 21. Now pay attention to what is going to happen here. We're loading b with 1 comma x plus. So we're first going to access x only. What is x already? Is 21. What is the data in 21? 0, 3. So 0, 3 is going to be written in b. And then we're going to add 1 to x. So x will be 22 after we access the information. So we're expecting b to be 3. And that's what happened here. It didn't add 1 before, it added 1 after we access the information. Now x is 22, so for this instruction we're going to access 22, which has 5, and then after that x will be 20. Okay, so we're expecting b to be 5. And that is the answer here, and x now became 20, but only after we access the information and the data. Here is a recap of the addressing modes that we covered. These are the main addressing modes that you're going to be using in most of your programs, and they're really helpful, and they all have their different usages. And how do you know which one to use? It depends on what you're trying to do and what your program is built to do. So we did the immediate addressing mode, and we learned that we're gonna access that using the pound sign. The direct mode, we're going to access that just by writing the number here. It can be either in decimal or in hex, and if you're going to write in hex, then don't forget the $sign. And if the number that you're trying to access here, the memory location, is bigger than FF, then it's called extended. Then we have the indexed addressing mode, and that is going to access the x plus 1 data. That's why you can see here the content is going to be the content of x plus 1. The pre-auto increment, we're going to add 1 to x first, then access that information. That's why a here is the content of x plus 1, and x is going to be added to 1. So x plus 1 is going to be the new x. Similarly for the pre-auto decrement. For the pre-auto post-auto increment and the post-auto decrement, we're going to access the information first. So you can see here the content of x, then x is going to change later. Thank you guys for watching, and I'll see you in future tutorials.